Hey there developers, it's Steve again, and I'm going to talk to you about spatial functionality in MongoDB on OpenShift. Foursquare actually uses MongoDB's spatial features for all of their check-in capabilities, and I'm going to show you those same kind of features today on MongoDB. So here's the agenda for today's talk. You're going to learn a little spatial, we're going to load some spatial data into Mongo, and then I'll do a query or two to show you how it works. Assumptions. My first assumption is you can use the command line. Everything I'm doing today will be used from the command line. And the second one is that you're a little bit familiar with MongoDB at the command line. If you're not, there's plenty of resources on the 10gen and MongoDB site that tell you how to do it. So you might be wondering, what is OpenShift and what is a platform as a service? And so this slide gives you a basic idea of what that is. If you think it's like Amazon, that's not exactly right. Amazon is what we consider more of an infrastructure as a service. You pick a server, you pick an AMI, you spin it up, you configure the software, you get it all to work together, you're responsible for keeping it up to date, you're responsible for security on it. That's infrastructure as a service. It's basically virtual machines in the cloud, and then you do everything on top of it. Software as a service on the top here, that's easy. Most people have used that before. That's Gmail, that's Salesforce, that's all sorts of other applications pre-built. Not so exciting for developers. What OpenShift is a platform as a service. It's made to make life easier for developers. In actuality, it's awesome sauce, right? The idea with this is you take the language that you want and you just tell the platform, I want to make a web app in this language. So for us, it would be RHC, app create, your application name, and then say Python. And that's it. We spin up Apache for you. We configure it all together. And then if you say you want to use Mongo, you just add the Mongo cartridge, which is extra functionality. We spin that up for you, and it plugs right into your development environment. There's no setting up the two to talk to each other. How do you get Apache and Mongo to talk to each other? It's all set up for you. No configuration on your part. We believe you want to spend your time as a developer writing code, not managing servers. So that's basically the idea of platform as a service and OpenShift. And now I'm going to talk some about spatial. And this is a new area for a lot of you as developers. The nice part about Mongo is that spatial is very easy on Mongo. There are other solutions which have a lot more spatial functionality, but they're much harder to work with, and you have to learn a lot. With Mongo, it's only about two types of queries, near and containment. Near means what's closest to this point that I'm interested in, and containment means, is this point inside of some sort of polygon? So like, is this restaurant inside of this zip code? That's what containment is. And that's about the only functionality you can do in MongoDB at this time. So because of that, it's very easy to work with. It's all laid out on one page on the MongoDB site. That's the link you see on this page right here. If you search in Google for MongoDB spatial indexing, that page will come right up. There's a couple caveats that you need to understand when using spatial on MongoDB. One, when it makes the index, it assumes all the coordinates are between -180 and 180. And that's because they're assuming that you're probably going to use coordinates that are on the Earth, right? And the latitude and longitude only go either to -90 and +190, or -180 and +180, right? With minus being west and south, and positive being north and east from Greenwich and the equator. And the other thing is, though, you can actually do any 2D coordinate system inside of MongoDB. It doesn't care about the units. MongoDB has no inherent concept of units with it. It just knows that one of them is an X and one of them is a Y. And it's going to index based on those and let you do 2D queries. So if, for example, if you're a chip manufacturer and you make boards, you could actually make the X and the Y be the dimensions of the board, and you can actually put all the points in for all the different chips you put on the board and do spatial queries on that. It could be the coordinates of your backyard. It could be the coordinates of a floor in a building. Any 2D coordinate system can be used in MongoDB. But know that if you go above 180 and -180, that you're going to have to change the index to accommodate for that. The last part is that if you do work on the Earth, lines of meridian get together as they go towards the pole. So a degree is not the same when you're at the equator versus being at the poles. And there is formulas inside of the MongoDB to take care of that. And the other thing is most people don't think in degrees. So when you take a coordinate off a GPS unit, that's usually latitude and longitude, which is in degrees. And so most people can't think in degrees, right? When it returns a result of distance in MongoDB, it's going to be in units of degrees if you're using degrees. And so if I told you it's 1.25 degrees to your destination, most people have no concept of that, unless they're a mariner on the ancient seas. So the way to handle that is, on that page that I referenced before, they have a formula which talks about how to convert from degrees of the Earth to meters or miles or kilometers or whatever unit you want to use. It takes into account the curvature, and it also converts it into a human readable form. That's the only caveats you really need to do. Now I'm actually going to show you some of the basics to using it. How to make it work? You need to put your coordinates into an array. So what you're seeing here is that there is a location field in my document, and there's an array that holds the coordinates. You have to be consistent in keeping x either in the first part of the array or the second part of the array. Don't keep switching your x and y's back, otherwise the results will be very crazy. There's many ways you can put the coordinates in. You can notice I've got several different examples here, but the suggested use is a field with a simple array with x and y being inside that array. And then the next step, once you put those documents in, is to make a 2D index. And so DB, my collection's name is places, and then you say ensure index. The field is location, back from the array, and you say it's of type 2D. And that's it. Those two steps now enable you to do any kind of spatial functionality you want in MongoDB. So that's it. Now I'm going to show you a demo with code and data that actually goes through and puts some spatial data into Mongo, and then make a 2D index on it, and then actually use some queries against it. So for the demo, I'm going to now show you some spatial data. We're going to load it into MongoDB, and then we're going to do some queries. So the first thing I want to do is show you the data. I downloaded it from the internet. It's all the National Park Service lands managed by the United States government and the Canadian government. So here you can see the documents in JSON format. We have a name field, and then that's the name of the park. And then we have a POS, or position field. And in there, I've put in all of the coordinates for the different parks. So -85, 37 means we're somewhere to the west of the Greenwich line, and 37 means we're somewhere north of the equator. So there's Abraham Lincoln's National Historic Park. Here's another one for Anacostia Park. All the parks are in there. And that is in JSON documents that we can import into Mongo in a second. I'm now going to go to the spatial script because I don't want to have you watch me typing in typos. So the first thing we're going to do is take that file and SCP it up to the app I've created before. Remember, before this, I created an application that had MongoDB embedded in it so that we could start importing the data. So here, we're going to copy this, go over to our terminal, paste it in. And because we give you SSH access and SCP access to OpenShift, you can use the tools you're always familiar with. There we go. We've uploaded the file. Now we're actually going to SSH into our gear that has Mongo running on it. So there's the SSH command. And there I am. I'm in my gear. As you can see, I can look at the files. This long random number is my username. We do that because of scaling reasons. And there you can see we've got MongoDB running, and we've got Python running. It's a Python application. The name of the application is called Parks. And by default in Mongo, we create a database called Parks that matches your application. The next step is we're going to import all of that park data into our Mongo instance. So here you can see the command for this. This is Mongo Import, which allows for bulk loading of data. The database is Parks. The collection we're going to call Park Points. We can create collections on the fly. The type of the file is JSON. You can also do CSV, but it was very hard for me to think about how to embed an array in CSV. Here's the file that we're going to work against. That's the park coordinate again that we uploaded in the SCP command. And then we're using the environment variables that we've put in when we put Mongo in. So here's the NoSQL DB host. That's the host for our Mongo instance. The user is going to be admin, and there's the password we gave. And so in a scaling environment, it's very important that you use environment variables. In a non-scaled environment, you're all told best practice not to use hard-coded IP addresses and hard-coded passwords into your source files. In a scaling environment, if you do that, it'll break because there's no guarantee about what the IP is going to be, nor the passwords when we auto-scale up a new instance for you. So please, if you write applications that you want to scale, use the environment variables we give you. We have a page in our documentation that gives out all the environment variables that we put into your application. So we're going to now do the import in the instance that we had SSH'd into. And there. It ran, and we've imported our 547 parks. So the next step is to actually start using Mongo at the command line. You can just go Mongo, and we're going to use parks, and there we are in our database. And then I can say show collections. And there you can see is park points, the one that we imported. So we loaded that data, and the next step is to ensure the index, like we said before. So we go over to the terminal, and we say ensure the index on our position field, and we want the type to be 2D. Done. Now our collection is totally spatially enabled, and we can start doing fun spatial commands. So for example, we are going to find all the points that are near minus 3741. Here's the command again. And there's our results. You can see that when we imported the data into Mongo, it created a unique ID for us. That's this field here. There's the name field again with the name listed, and there's the position. These results come back in distance sorted order, with the point on top being closest to the point that we asked for, which was minus 3741, which we can tell by the results that we got back is somewhere up in the North Atlantic somewhere, and I'm not quite sure. But I think it's kind of fun to kind of guess. Because you can see our first points are somewhere in Canada, like Terra Nova, Gros Morne. These are all Quebecois or normal Canadian names. And then down here, you can see we're going to start getting into Acadia National Park, which is in Maine. Right, so that has to come back in distance sorted order. And those are all the parts that came back. And so in Foursquare, this is the same functionality as when you fire up the application, and it shows you a list of the places near you. Usually that list is not very good, so we're going to have to restrict it to something closer. The reason it's not good is because Foursquare has a lot of points, and it doesn't know which one is most relevant to you. So let's make it a bit more relevant. We're going to say a compound query for MongoDB. In this query here, we're using the find command again, and we're looking at the same point, but we're also going to do a regular expression check against the name field. We're doing a regular expression, case insensitive, with the word Lincoln anywhere in the name field. And so we go back to our terminal again, paste that. Actually, before I paste that, because it comes back so quickly and they look so similar, I just want to get rid of that line and put a couple spaces in. There we go. And there you go. Now we've only returned a few records because we've restricted it by the name. And they again come back in distance sorted order from that point off in the Atlantic. But you can see they only contain the name Lincoln in them. So President Lincoln's cottage at the Soldiers' Home, probably somewhere in DC. The Lincoln Memorial, definitely in DC. The Abraham Lincoln Memorial birthplace. Now you might think that's in Illinois, but it's not. He was actually born in Kentucky and then moved to Illinois when he got older. So then you can see here's Illinois picking up later. His is National Cemetery and the Lincoln Home National Historic Site. So again, these are in distance sorted order, but they only contain Lincoln in them, which in Foursquare would be you're at a sushi restaurant, you type in sushi and hit search, and it's going to show you all the sushi places it knows about that are closest to where you're on. And it's getting the coordinates from your phone, right? So there we've shown a compound query. You might be asking, well, how can I see the distance? And so what we're going to do now is actually do a query that finds the distance. And to do that, you do a db run command, and we use Geoneer. So the command we're running is Geoneer. We give the collection we're going to hit against, which was park points. The near is the same point, but also we can change the number of results we're going to give back. So for example, with these find commands, we always get back the default cursor size, which is 30 results. Here we're going to say, I only want 10. So we're going to do 10 near that place off in the Atlantic Ocean. Let me make sure I copy that. There we go. Go back and put a few blank lines in. Run the command, and we get our results back. So Geoneer gives us a lot more information. It tells us what it did the search against, which was park points. It gives the geohash. If you want to use that as a cocktail party, you can say that's the geohash. That string of binary numbers is the geohash for minus 3741. And then we get our results. But this time the results come back in an array, and the array has the documents embedded inside of them. And the first field is distance inside the results now, as opposed to just the spatial object. And remember that those distance numbers are actual latitude and longitude, because we put latitude and longitude in as our distance as our coordinate units before. So this means that that distance of the Terra Nova National Park to minus 3741 is 18.58 degrees from minus 3741. So that's why you want to go back to that page on the MongoDB site and figure out the formula to either change that out to miles or kilometers. We get the rest of the same information, the ID, the name, and the position again. And then, for fun, at the bottom, you get some diagnostics on your query. So the time it took, the B-tree locations it hit, the number of objects scanned, the number of objects loaded, what's the average distance of the result set, and the maximum distance of the result set. Right? So that's the Geoneer command, and it gives you a bunch more information. All right, so now we're actually going to create a CheckIn database. And the architecture isn't exactly the one you might want to use for a CheckIn database. Mongo has some different data models. You might actually want to store the collections with the user of their check-ins. But here we're just going to make a separate check-ins, and this will hold all the check-ins that happen. So we're going to create a collection called CheckIn. Put some more space in here again. There. I've now created a new check-in. Then I'm going to make an index on the position field, even though there's no records in there. So now, if I want to insert a record, here we're going to pretend this is a check-in. Where would you get the coordinates? You'd probably get it from the user's phone, right? All phones, all smartphones now, and even some of the not-so-smartphones, like feature phones, as well as most modern browsers, can give you the coordinates of the user. You would take that in your query, and your insertion query, and put that in there right there. So we're going to make a created field. It's going to have a date. It's going to have a notes field and a position. So this will be our first one, and the notes is just landed. So we're going to pretend this is somebody coming off a plane. Done. We've put it in now. So now, if I do a query again against the check-in collection, so same syntax as before, you'll see our one object that we did. One of the nice parts about MongoDB storing its data in BSON instead of JSON underneath is that you can have real dates. So there's an actual date type being stored for the creation date. There's the notes, and there's the coordinates. So that is a spatially enabled database now. Or spatially enabled collection, I should say. All right, so now we're going to actually use the save. This does an upsert, so use this with caution. What an upsert does is it basically says, is there a record already in there that matches this? If so, this is an update. If not, create a new one. But since we're not passing the ID for this first one, it's going to create a new record. It usually checks against the ID to make sure that record doesn't exist. So here we're creating a new one. The problem with using this is if you use it to update a record that already exists and you don't list all the fields, any field that you don't list and put information back into will get dropped in the new record. So the preferred way to use an upsert is this format here, where you actually get the record out and store it as a document. I need to actually put the ID in over here, so let me find the ID from that first record we inserted. We're going to change where it really landed. Okay, so here's the object ID from that first one. I copy that. I put that in here. Now, I'm going to actually do a find one. So I'm going to find that document and store that in a new object called mydoc. There we go. Then I'm going to take the mydoc.notes field and say, this is really the landing. So I'm updating that notes field from just landed to really the landing. It's done. And now I'm going to say to the check-in collection, save that document. And because there's an ID there, it'll overwrite it. So if I go back now and do my query, the find, well, it should have two documents, right? This is the new one we created, the second one we created because its position was closer, as you can see back here. And the original one, which we updated, now has a new notes field, really the landing, although the coordinates weren't updated. In the same way, we can actually update the coordinates field on the mydoc again. So let's do that query again. right? So there's my doc, which now has really the landing. But instead of changing the notes field, this time I'm going to change the coordinates field. So we're going to say PaaS. And then we're going to put in an array. And we're going to make it closer this time. So let's make it actually minus 37, comma, 41. So we're actually putting this right in the, so we can change its search order. Oops. I forgot to get rid of that quote. There. So now we can do the same command again to save that document. And now if I do my spatial query again, where'd my spatial query go? I'll just copy and paste it again from up here, rather than watching you have me scroll. And now you can see really the landing has the new coordinates, and it's the first one returned. So this is a good functionality that you could use if you wanted to keep the current position of a user, right? You could pull the user by their ID, and then every time they move around, you update their position, and then you would always have their latest location. And so you can see the index updates automatically as well. So that concludes the demo part of the talk. Time to wrap up. I hope you saw how easy and fun it was to do spatial applications with MongoDB on OpenShift. I have also now given you all the tools you need to create your own Foursquare application. Have at it. What's more realistic for most application developers is some mobile or asset management system that tracks things in the field. For example, water meters or telephone poles. The group can go out and say, I want to check in at this pole. It finds the pole near them. They can write some notes and then check those notes in, and then you can have someone checking it in the back end. I also hope you see how easy it was to develop with OpenShift. You can check out my blog post listed here that talks about using Spatial on Mongo. And if you haven't signed up, now's your chance to go get a free account for free servers. Thanks.